We have a Facebook group. We have a YouTube channel. We have a Twitter account. So find us in all those places. We will try to stream live to Twitch and YouTube this evening, assuming Clayton's face gets happier. But with that, wanted to let Tech Systems say a few words. And thanks to Pizza. So.
My name is Caroline. I just started Emma. Work for Tech Systems, focus with applications development. Introduce ourselves to you guys. We're super happy we're providing some food today. We'll leave some of our business cards in the back table if you all want to reach out. If you have a table on the market.
Thank you. All right, and with that, we will go out afterwards to one of the local restaurants or local bars, maybe the Avenue down the street or somewhere close like that, on your own time. So please drink responsibly. If there's any leftover pizza or drink, feel free to take that with you. If not, the OZK folks will eat it in the morning. So with that, we'll let Kevin take over.
I need just a couple more seconds here. My computer's rebooting.
All right, so
we'll get to do a little
show of hands. First time at St. Pete.net meetup. All right, well, liar. Welcome. Appreciate everybody coming out. We do try to make it fun and interesting, and interactive and be a community. So please network, please do socialize, please talk to one another. If you have questions, feel free to ask. Most people except Aaron are helpful. And he's also helpful. He's also a lot of fun to pick on. So if you want to pick on somebody, you can pick on him. Let's see. What else? Kevin's still rebooting. So
yeah, I'm trying to get the internet here. So we got a couple different avenues. We got some backup plans here.
So he's got a device here called the football. The CrowPi, and I'm sure we'll show some details off on that. Raspberry Pi and all kinds of sensors and fun stuff on that. Any questions? So who are the newer developers in the room? Yeah. Welcome. Are we all .NET? C#, JavaScript, Python? Yeah. Angular, React, something.
I was going to point out you got a couple graduates from your other hosting facility.
Suncoast Developer Guild graduates, recent grads.
Nice.
Congrats. So how do you like the program over there? Fantastic.
Did you get jobs? Just started to look. What started looking good?
Sure.
Hey man, better than Win Dixie, right?
Yeah.
All right, still trying to get on the internet here.
Yeah, so next month at Suncoast Developers Guild, we have Carl Franklin coming in. He's doing a Blazor Roadshow. Blazor is a technology, Microsoft Technologies that allows you to run C# in the browser. So the server-side piece shipped with .NET Core 3.0, and the client-side piece that runs on WebAssembly in the browser is slated to be general release early this year, since it is 2020 now. So Blazor is a fun technology. You can find all kinds of demos and YouTube and podcasts and all kinds of people going crazy and talking about it. Carl Franklin is one of the co-hosts of the .NET Rocks podcast, and they're up to 1,700, 1,800 episodes now. They do. If you're interested in technology and podcasts, give them a listen. It's a lot of fun. So Carl's doing a road show. I think he's starting in South Florida and going north through other states as well. Probably. I just happen to know a couple of stops in Florida. So he reached out to us and said, "Can I come? I'll bring my own sponsors. I'll bring my own food. We'll talk for 3 hours, and it'll be a lot of fun." So if you haven't already, please RSVP. I'm nervous that we might.
What is that?
I'm nervous that we might fill up, so we might need to cap it off at some point. So please do RSVP.
What is it?
It's Wednesday night, March something. So it's an off night. So we regularly meet the first Tuesday of the month. This just happens to be when he's coming through town. So we are adjusting to meet his schedule.
Will the recording be available later?
With this one or this one? Yes.
Yes.
Clayton's face is now happy, so we're good.
As long as the internet holds up.
Are you having some challenges too there, or just for me?
Well, Kevin's on his own internet.
I should be good. You're good? Okay, cool. Well, thanks everybody. Thanks, John. How's everybody doing tonight?
Good.
IoT with the Bite Master here. So a little bit about myself, founder of Soft Logistics. Our company has a platform for building cloud-based IoT applications. Early background in electrical engineering, and I was a communications sergeant in U.S. Army, but lots of other stuff beyond that. So this is our new mascot, Software Logistics. 4-month-old Jack Russell Terrier. Call him Arduino. We're using a gimbal to find him. Does anybody know what a gimbal is? You do? Okay, cool. So I got a gimbal in my pocket here, so I'll show that in a second here. So the idea is, around his collar there, we actually have one of these little kind of Bluetooth low energy devices. And let's do a quick little demo on that. Because one of the things obviously is, where's this little...
wear it and run around.
There you go. So we got this crazy little Jack Russell running around the house, so where are we going to be watching him? So here, grab that. Good catch.
Bark, bark,
Bark, bark, bark, bark, bark, bark.
bark.
And I beacons. So this is not that terribly. There we go. So I've got 2 things on here. So there's going to be a lot of things we cover beyond just kind of like the CrowPi on here. So let's go. Camera. And
Keep going, Joe. That's going to you.
that's me. But this should show up on there, and it looks like that's my forward-facing one. I should have one more camera on here. There it is. There we go. So this is kind of a neat little device. They're really, really inexpensive, and you can see that I've got 2 of these devices out there. One is in my wallet, because if you ever talk to my wife, she loses stuff all the time, so I put one of these little kind of gimbals in my wallet, which means that I can figure out where my wallet is at any time. So you have one over there right now? Okay, so you got it. So go walk back there. So you can see basically we're getting a distance on there. So this isn't necessarily something that uses GPS, but it's just a really kind of very, very low energy type of device that can be used to be able to monitor kind of like where things are. So we know as we're walking around looking for the dog in the house, it's really, really far away, and you kind of start walking up here again. We'll see that start turning green on the bottom one there where it says IoT demo. It'll take a second or 2.
What's
Going
the
down a
beacon
little
on that? Is it just straight RFID or not?
No, this is actually Bluetooth low energy.
Okay.
So it's like I say, it's something that lasts for about 6 months. It's kind of a neat technology. So I think Joe posed a question earlier this week. We called him Arduino. What are we going to do with IoT? So that's the first answer there.
Nice.
Kind of a fun little project. Also put it on the cat to see the cat get chased around the house by Arduino. What's that?
The tile devices, don't they use it?
They're very, very similar to that. Yeah, exactly. The tiles I think maybe are just slightly more expensive, and what's neat about this is that they are really kind of meant for developers out there. So let's say you're building some type of application, they have a real kind of comprehensive API to be able to program and get the information. So the idea is really to kind of build applications around there, where tile's more of a consumer-facing device. So what are we going to cover tonight? Lap around of a bunch of IoT topics, connect from anywhere. And that's not working so well so far, but we'll see how it works when we get back to it. CrowPi, efficient coding, the best way to actually kind of modify code on a embedded device there, in this case running Raspberry Pi, a version of Linux. CrowPi.net, pretty exciting. And then as an added bonus, if anybody, how many people do Arduino type work? How many people? I see a few hands out there. How many people like the Arduino IDE? No hands. I've got a really good solution for you to show how to do that type of programming. And then look, no Wi-Fi needed. So one of the things our company's been doing lately is actually using cellular technology to be able to connect to the internet, because a lot of times out there, when you're building these IoT type solutions, you're not necessarily going to have the ability to get on the company's Wi-Fi. There may be security concerns out there, or they may just not have Wi-Fi where you need to be able to get on there. And then finally, once we kind of get done going overview of everything, then we'll actually go ahead and play with some sensors. So connect from anywhere. One of the challenges that we have kind of doing demos, our company does a lot of IoT work, and a lot of challenges we have is how do we get these things on the internet? Because as I say, without the internet, you can't have Internet of Things, and without things, you can't have IoT. It's a whole nother talk, and maybe some people saw me when I gave that before. But we really need a mechanism to be able to get on the internet, and as I was mentioning before, relying on a company's Wi-Fi or external resource to be able to get on that for like production type of scenarios isn't necessarily the best approach. So what we have here is a really cheap cellular modem from Netgear here, which gets me on LTE, little antenna, and I've got a simple router that I can connect to with Wi-Fi to be able to get onto the network. So I've kind of set my own little network up that can run from anywhere. What's also really important about that is a lot of devices that you'll be using out there won't necessarily have any type of Wi-Fi connectivity associated with them. So what you may need to do is actually plug into an Ethernet cord, kind of like into like an Ethernet port to be able to hook up your IoT device. This kind of lets you build that type of scenario so you can actually have something in place where you can go and kind of do some serious demos out there. So again, like I say, what we have here is a simple, just a real cheap $30 router, cheap $30 router with a access point built into it and a switch in there. And we also have a Netgear router where we plug a little SIM card in it and be able to get that onto the internet and be able to dish out the IP address and so on with the antenna. Just makes for a lot more reliable type demos, and hopefully it'll be reliable tonight. So far it hasn't been too great, but we'll get her going here. All right, so that's really kind of the scenario that we set up here as far as being able to get on the internet with the whole standalone infrastructure. How to efficiently write code with the kind of with this type of environment. How many people like Vim? Oh, we got one hand, just one hand, only one hand, two hands.
I can use it. I don't
Yeah,
necessarily-
well, there's a difference between liking. I can use it too. But what about Nano? Nano's a little bit at least more tolerant for me, but that's kind of the one that I use. Okay, so for you guys, just go ahead and take a break and chat amongst yourselves. So for the rest of us, I came up with a really kind of neat scenario to be able to work on my PC or my Mac to be able to modify code running on my football or my Raspberry Pi in this case. Consists of using Visual Studio Code. A lot of times when we're building these types of scripts, we're building like a Python script, a PHP script, maybe some Node.js. And sure, you can modify it directly on the device, maybe SSH in, but there's kind of some better ways of doing that. Using a program called Terminus. Anybody know about that one? It's basically something that lets you manage a large number of SSH connections talking to your other devices out there. So again, what we're really talking about here is a scenario where we need to modify some code that's going to be running on the CrowPi here. And got a keyboard that I could be working on there, or I could actually use kind of like the onboard keyboard there to be able to modify the source code on there. Just not a really good way of doing that. So what we want to do is we want to be able to work with the programs and the code running on the Raspberry Pi, but we want to be able to do it in maybe a little bit slightly more modern environment.
What's that thing?
What's that?
What's that thing you're talking about?
The CrowPi?
What's a CrowPi?
We'll get into that. That's a different topic. It's a Raspberry Pi, but for all practical purposes, it could be a standalone Raspberry Pi. It could be just a Linux box running in the cloud somewhere, but this is just kind of a neat way to be able to modify some of the scripts that are running on your Raspberry Pi on a more modern environment. Another nice thing about that is you have the ability to kind of integrate some source code control on there. Sure, you can do all the Git commands down here, and that works. There's nothing wrong with that. But some of us like working on kind of a more full-featured system over here to be able to manage the file system and look things like that. So we have Terminus is the thing that actually lets me connect to the CrowPi there. And then finally, the component we have is something called WinSCP. WinSCP lets us synchronize files between my laptop and the actual Raspberry Pi itself. So let's go take a look at what that looks like. If our connectivity, ooh, we dropped off. Let's see if we can get this up and running here again. I want to connect to the Soft Logistics one, and it should dish me out a nice IP address. Okay. So again, the idea is really to be able to use our router and our kind of access point or our switch there to be able to produce a more reliable environment to be able to do these demos. For some reason, this just doesn't seem to be working good right now, but we'll see once this connects here and see what we can do.
Lights on.
Lights on. Lights on, and it says it's got internet on my little switch here. No internet. Okay. Let's try something once here. Ping. Demo 1. As long as that comes back with an address, I think we're going to be all right. So then we're gonna come over here and edit this and type in the address, in this case, November Demo 1. And as long as we get a kind of SSH terminal, we're good to go. This is looking really good here. So that's not very readable, is it? Let's see if we can do something to be able to get a little higher quality resolution going on our screen. I can always do the Windows P. I'll just do that one. So the other program that we want to have running here is something called WinSCP. And what WinSCP is essentially something that lets you synchronize files between the file system running on your Raspberry Pi or your Linux box or whatever type of remote connectivity out there that you have that has the files that you want to work on. So in this case, it's not 10.1.1.5, but new IoT demo 1, I believe. I'm going to save that. Go ahead and log in and connecting the host. This is looking good. Perfect. All right. So now what we've done is we've got two file systems out there, and let's kind of blow it up a little bit here. So we're saying that on my local file system here, it's still not very good, is it? There we go.
Oh, there you go.
Okay, that's much better now. So on my D drive, I've got CrowPi, and over here, I've got the actual kind of path within my little Raspberry Pi where these files exist. So far, so good?
Yep.
So what I'm going to want to do next is come up here and go under, where is it again? Commands and keep remote directory up to date. And then all I got to do here is come back and say start. And now it'll go ahead and make sure that the files that I have on my device there get synchronized to my PC, and all my files on my PC will get synchronized down to the device.
So you're gonna make your code changes here, and then you're just gonna sync them up with
Yeah, it
WinSCP?
automatically works. So basically I can work on my desktop here. I can work in, shall we say, I don't want to offend the people that like Vim. I guess a lot of people really do, but a more modern type of IDE like Visual Studio Code to be able to modify those files.
Mhm.
So I'm going to come up here and open up Visual Studio Code. And let's see if we can. Here's a neat little trick that I just learned recently. So is that readable? No, that should be somewhat readable, right?
Yep.
I'm going to go to D:, I'm going to go to CrowPi, and now all I got to say is code with a period on it. Tell me what that does. Somebody tell me what that does. What's that?
Opens the current folder code.
Perfect, exactly. So a lot of times what's really neat about Visual Studio Code is you're not necessarily working in a project-based environment. You're really just kind of working on the directory structure that contains the code that you're trying to manipulate. So in this case, now we have the directory structure of the files that are out there. And let's take a look at a nice simple one. Motion, that's a really simple program. Basically, this is, if you're not familiar with Raspberry Pi, this isn't necessarily going to get into a lot of the details of Raspberry Pi programming tonight. This is kind of give you an overview of what the landscape looks like on how to do these types of things. So we might spend a little time talking about it. If we have any more questions about how Raspberry Pi works and what some of these commands are, please just kind of reach out to me afterwards, buy me a beer or something like that, talk about that. So the idea what we're looking at here is basically a Python script. How many people know Python? How many people love Python? I'm really starting to love Python again with a lot of machine learning type stuff. It's definitely worth time investing learning it, because if you're going to be doing that type of work, highly recommend Python. That's kind of the language of machine learning. So anyways, this is a very simple program, and it's, if you don't know what's kind of different about Python as opposed to other languages, you don't really have those squiggly brackets or like begin and end blocks. Everything is indent based. That's kind of a very important concept that you need to figure out when you're working with Python, is that everything under this while statement that's indented will run in that loop. Okay, good enough. So basically we're working on this program right now, and I'm going to make a simple change on here saying motion was detected. You know what, let's actually run this first and then we'll make that change. I'm going to come back to my Permeus program. Where's it running in this?
If you forget to indent, is the error pretty recognizable?
It will be. Yeah, well, that's actually a good question. We'll show you that. So I'm going to go ahead and run my Terminus program. And that's still not read. I don't know why it's so hard to read there. But there we go. I think that's probably a little bit better. Okay, so let's do I'm in Linux, so we'll do an LS. When you get a CrowPi here, which we'll get into the details of it more later, but the CrowPi comes installed with a little micro SD on there that has all the programs and your examples to get started with. So we'll go in there and we'll do another LS. Oh, examples would be a good place to start here. So we'll go into examples. I also want to say that as I go through this stuff, I talk really fast and I'm probably making some assumptions. So if people have any questions, it's your fault, not mine. If you have questions, you're not stupid. I'm talking fast and I'm assuming things. So raise your hand and please ask your questions.
He hates the weak.
Do not. I just hate you. So I go way back. Okay, so basically what we've got right now is these are the example programs that come on the CrowPi. And to start a Python program, I'm just going to simply say Python motion.py. That'll go ahead and thank you. Motion.py. There we go. So nothing moves. Trust me, I'll show the details of this device later with the camera. But I've got this little motion detector on here, and you can see motion detected. Boom. Cool. Nice and simple. It's kind of one of the neat components of the kit itself. We were able to do all this without doing any type of electronics. All right, so now I'm going to hit Control C, which will exit my Python program. You can see that. Control C. There we go. So now we're back at our it's not really kind of command prompt. It's prompt here in Linux here. So now I'm going to come back to my program in Visual Studio Code. I'm going to say, instead of motion detected, I'm going to say motion was detected. All I got to do now is hit save, which is Control S, I believe it is. We got that little dot up there. If I hit Control S and that goes away, we'll be in good shape. Good, so we saved it. At this point, I can come back to my Terminus program, and it'll say that, let's see here. We synchronize that file down to the device down there. So basically what we're doing is we're working in a modern environment like Visual Studio Code. One of the real beautiful things about Visual Studio Code that I will have to say that even if you do like Vim, you would appreciate some IntelliSense once in a while to be able to kind of give you some idea as far as what the code that you're writing will do and being able to get the built-in help type of thing. So that's kind of one of the benefits of using Visual Studio Code. So now if we come back here to Terminus, all I can do is hit my little up arrow and bring that down here again. I'm going to hit Escape, Control C. So basically when you're working Linux, a big trick if you don't know, up arrow brings up the last programs that you're running. So now what we can say is nothing moves, and with any luck at all, we should be able to say nothing moves. Motion was detected as opposed to motion detected. So again, that's a really, really simple example, but I do a lot of this type of programming where I'm actually working on a different box out there to be able to write some little Node scripts or maybe some Python scripts or whatever your favorite language is. And it just provides a lot of value to be able to work in a quote-unquote more modern environment to be able to modify the code on the device itself and being able to use your file system, being able to use, if you like the Visual Studio way of being able to check files in, you can do that within Visual Studio Code. So it's just something that helps you be a lot more efficient writing these type of programs. Any questions on that?
That's pretty good.
Cool,
So
thanks.
it's just that one little script in the VS Code that's detecting the motion?
It is actually, yep. And we can have buy me beer later, I'll tell you exactly how it works. You don't have to buy me beer, I'll tell you exactly how it works. We'll get into some of the sensors later, but the idea here was basically just how to set up an environment to be efficient, to be able to do this type of programming.
Question.
Yes.
Is that what you meant also by a better IDE for Arduino programs to set up this particular sensor?
Very good question. Visual Studio Code is the right answer, but it's slightly different because we're using a different transport to be able to talk to the Arduino. So I can't remember where it's at in the presentation, but if I can get you hold on to that question for just a couple seconds, we will definitely revisit that. Okay, so this is something, since we're stpete.net, we should probably go ahead and do some type of .NET stuff tonight, right? Does anybody mind if I do .NET? I kind of like .NET. It's kind of language I prefer if I have my choice on things. Anybody minds? Nobody minds? Good. Somebody's groaning over there. Okay, so what we're going to do now is bring up our old friend Terminus and hit Control C. We're going to go ahead and make this a little bit bigger. I've got another little note here. It's kind of important note actually. To be able to get Raspberry Pi, .NET running on Raspberry Pi, just that's a link to be able to get you there. bit.ly.raspberry-pi.net. That'll give you the instructions of how to set it up. Unfortunately, the steps that you would normally use to be able to set it up on Ubuntu, setting up .NET Core on Ubuntu, don't quite work, so there's kind of some extra jumping around you need to do, and go ahead and click on that link. That'll get you going. We're not going to do that. I'm going to assume that we've already done that. We're kind of got lots to cover. So I'm going to come back over to Termius, and I'm going to make this a little bit bigger. I'm just going to do a quick refresh here of what the actual commands are again. So if anybody can help me here, .NET new console -O and the name of the project we're creating. So John, you got to remember, you got to help me remember that if I forget that. Okay. Okay, so now what we're going to do is if I run .NET on here, oh, that's not good. I think I set up symbolic links earlier, but I think I set them up for the session and not for the system. So when they came in the next time, I lost them. It's going to take a little bit to set that up again. So let me just see if I can do it real quick here. It might not take that long. It's actually a pretty impressive demo to be able to. How many people like .NET? Come on, everybody's hand should be up here. So if you like .NET and you like writing programs for the Raspberry Pi, you can do it on You can do it there. So I'm going to go here, and I think it's just a couple little links that we might be able to get to real quick to be able to set up that. No, we can't. Okay. Sorry. So basically what we can do is run this command here, .NET new console, hello stpete.net, and then once that's done, that creates your application out there. We go into that directory, we can say .NET run, that says hello St. Pete, or whatever that C# program is that we're working on. But we got lots to cover. We may come back to this one. It's kind of a neat demo to be able, like say, writing C# code that runs on Raspberry Pi, and it's something that, I mean, there's a lot of reasons why you want to do that. One thing is, I personally like writing in C#. It's my favorite language for building large, sophisticated applications. It's very efficient. But there's other reasons why you want to do that. One of the key ones is our company's product actually is written in .NET on the desktop here, but we can load that up in a Docker container, run that in Linux on a very, very cheap VM out there, and being able to offer up a .NET application that we wrote in a very, very small amount of time that offers up a lot of functionality, a lot more functionality than if we actually went and built this in something like C or C++. So it's really pretty exciting with .NET Core. Anybody else have any questions about .NET Core? It's really, really kind of neat. I mean, have you talked about .NET Core here really in this group at all? So cool. Yeah. Definitely something that you want to spend some time on. And again, that just starting when you're working in this type of environment over here. Let's go back here. When you're working in this type of environment, you really don't have an IDE because you just have a command prompt. So what you can do is you can do like a .NET and so on, create new, and then create the whole project structure. You can go and modify a C# file. You say .NET run, it'll compile it and run it all kind of running in this type of terminal program here. So without an IDE, you can do everything with the console. I know a lot of people like IDEs, and they certainly have their place, but it's certainly nice to be able to do things very, very quickly and efficiently at the command prompt. All right, so VS Code and Arduino, to your question. That's a very good question, actually. So what we got here is I'm going to open up a different directory structure now. And if we remember right, we come back over here to DOS, to my command prompt, and we can say, I think it's electronics, hardware, and in this directory I can simply go into the Sim900 directory, I believe it is, and I can say VS Code, come on, Kevin. There we go. Stop fat fingering and things will work much better. Okay, so Arduino programmers. We got some Arduino programmers in the room? Some Arduino programmers up there. Normally what you do is you use the Arduino IDE to be able to upload your programs to Arduino. Even with the Arduino IDE, you can still put Visual Studio Code on top of it, and that's still a much better way of doing it, at least in my opinion, than using using the Arduino IDE, just because you have all the IntelliSense and being able to navigate files, and it's just kind of a better way of viewing your project like that. So that's not a bad way of doing it. There's something out there called the Arduino CLI, the Arduino command line interface. And what we can do with command line interface is being able to execute programs running on an Arduino type of device down there and being able to just kind of run them a lot efficiently. If you have a big program out there that you're trying to build with Arduino, it takes a long time to run, and there's just a lot of other challenges with that. Also, if you've done a little bit of Arduino programming, you know that you have to bring libraries in. You have to bring libraries in to make your web server, your Wi-Fi, or like your JSON parsing. One of the neat things about using Visual Studio Code is you can set up tasks out there to be able to use the Arduino CLI, which is, again, different than the IDE. It's basically a command line program where you can pass parameters to, and you can kind of use it like a package manager. I'll show you what I mean by that. That's actually one of the more important parts, I think, about using Arduino. Arduino is actually being, people are interested in this, right? I want to make sure that I'm not, okay, good. Okay, so one of the interesting things about Arduino is it's more than hobbyists right now. People are using it in the real world and industry out there to build systems that they deploy out there, just because there's such a wide set of libraries and it's a great way to build embedded systems. So saying that, when you build these types of systems, they get a little bit more sophisticated, and when you build these sophisticated systems, you want to have some type of way to be able to manage your libraries, right? And let's say I want to bring in the latest MQTT library. That'll be one of the talks here coming up here, what MQTT is. But let's say I want to bring MQTT in, I want to make sure I got the latest one out there. How do you do that right now with Arduino? You go through the user interface, click here, do a search, do an update, all that type of thing. And it's just really not a good way to be able to do that. It's really hard to set up a development environment when you bring somebody else on board. You have to have basically the steps saying, click here, install this. So one of the things with the CLI is you can actually use tasks to be able to build libraries. So let's take a look at what they look like here. And I'm going to come over here to, I think this is the wrong window. Let's see here, hardware, sim, here we go, this is where I want to go. And now if we go under Visual Studio Code, we have, open the wrong folder, I'm going to open the wrong folder. Please bear with me a second. I'm going to close this down, pull some of my windows down so I don't lose myself here. Close. I think I need to come up with directory. Code. Let's try this one more time. And here we go. This is looking better. So we can come under Sim 900L. We got the VS Code on there, and oh, firmware. My bad. There we go. This is looking better. So Visual Studio Code tasks. People know what those are? Tasks are really, really cool to be able to build up automated things that you can build as part of your build process. The one that we have here that's really, really interesting for what we're doing is install libraries. So one of the challenges, like I said before, it's still small. When you build an Arduino application, you have to say, okay, select this file and do it manually, do that. If you're building a team, if you're building an industrial strength product, if you're building something that you want to be able to have some type of CI/CD platform out there, you really just can't, it's just not a feasible solution to be able to do that. So in this case, what we can do is we can create a new kind of label out there that will run as a task. And in this case, we can say Arduino CLI, install, and then these are the names of the libraries that we want to install. So if you're familiar with like NuGet or Maven or something like that, you know that each kind of package out there has a unique identifier, and these are the unique packages that you can bring into your application. Really, really important point to be able to work on this type of thing, this code here, to be able to manage this. The other part that's really interesting here is we can go ahead and let's take a look at how we can compile it. We can actually, I'm going to see if I can find two examples here. Done. Here we go. So I've got two examples on here. One is compile this tcall application, which is something that talks to our SIM cards on the things that people to hook up to the cellular networks on there. So this one will essentially just compile it and tell me if there's any errors. But if I want to be able to upload it, I just simply put the port that I want to upload it to and say upload on there. And then at that point, it would actually go ahead and send the program to the device to be able to execute on there. So again, is this A lot different than what you'd be doing if you're using Visual Studio Code on top of the Arduino IDE. Not necessarily all that different, but this just gives you a lot more functionality as far as being able to send programs to the device down there. The final thing that I want to show you here is when we come down here and we look
So now,
at.
do you set that up just like a piece at a time? As you need a new library, you go ahead and update this file?
Yeah.
So the next time you run it, that's already done for you? Is that the way you're talking about
That's
using
exactly right. And think about that. You're a hobbyist, right?
Right.
And it's not that big of a deal for yourself. You kind of know what there is. But let's say you got a team of 5 developers that are
Right.
working on this, because this is kind of where some of this stuff is going with Arduino. You don't want them to have to bring you over and say, oh, which do I install? How do I set up these build scripts? So the Arduino CLI lets you actually build up some automated scripts to do some CI/CD type of things, continuous integration, continuous
Right.
deployment things, to be able to do the same types of things you would normally be doing in kind of a large enterprise EE type application, but sending that down to a simple Arduino down there.
Yep.
Make sense?
All right, yep.
Cool. So the other thing we can do here is we can say start GPO001. So this is another program that we have a part of the scenario here. What we want to do here is when you're working with an Arduino, normally you're talking via a serial port. So you're doing your programming and then you're sending the data, not over the network, but it's hooked up via some type of kind of like USB cable, which serial cable that pushes the data down to it. So in that case, what you're doing is you're using the serial port to be able to program it. But a lot of times when you're building these little kind of embedded devices like here, how do you know what's happening on there? It's like, well, maybe got some lights that show up every once in a while, or maybe something's kind of sending some signal out there, but it's really, really difficult to program. So what you want to do is you want to be able to set up your environment so you can actually reflect information back to you, and that's over the serial port. But how do you balance that? Because I'm using the serial port to be able to program it, but I also want to be able to send the data back to my device saying how it's working. So in this case, what we can do is we can actually build up kind of what's called a compound task within Visual Studio Code, where the first thing we do is we close the serial monitor, which is a task somewhere else that we define. Then we compile the program. Then we clear the serial monitor. So the next time that we start, we have a nice fresh little screen there to be able to see all the data coming back to us. And then finally, we open it to be able to see the data come through. So does that make sense? So again, it's just really setting up some kind of automated scripts that there's really no way that you could do this if you're using the standard Arduino IDE or even using Visual Studio Code on top of the Arduino program out there. Make sense? Any questions? So I know we're covering a lot of stuff. I'm not getting into a lot of the detail stuff here because I can post this stuff. I will also have some cards with me. If anybody has any questions, please feel free to contact me and I'll kind of answer some questions. But just kind of laying out the landscape for doing this type of work.
So right now you have the Arduino and the Pi device on the same network.
Well, so the Arduino actually is hooked up via something called a serial port. And again, that's a great question, something that I just assumed people knew what a serial port was. And I'd say the people with gray hair like me might, but a lot of people don't. They're just not used that much anymore. Serial port is something that just sends and receives data over like 2 wires. They don't have like an IP address or anything like that. Very, very common back in like the 80s and the 90s to be able to send that. Even like a lot of stuff in embedded systems these days, they're still pretty popular. But it's not something where it plugs into the network directly. You actually have to hook it physically to your machine and you establish a connection. So one sends data and one receives it as opposed to the network. That's a really good question, though. Thank you. Thank you for keeping me honest, by the way.
You do have an antenna plug into yours, right?
Some of them I do. Yes, exactly. Depending on how much time we have. What time do you usually end at, or? Midnight? Oh, I think I got to get a beer sometime soon, so I'm not going to go too long. But I'll talk as long as you guys are interested. I love this stuff. I love this stuff. So we may come back and we'll look at that a little bit later, but yes. So like I say, one of the interesting things that we're doing as a company right now is we're figuring out the right way to be able to use these little SIM cards, that plug into these little types of devices here. And you know what, once we get done with the meeting, I will give folks a tour of like the kind of the hardware and kind of discuss that in more details. But at a real super high level, this little device here has, let's bring up the camera. And where is my, there we go. It's not very clear. This little kind of thing right there, this little block there, it doesn't really matter, I guess, is actually a cellular modem. So, you know, people probably know what modems are. They're able to modulate, demodulate, send signals out there. That one is something that hooks up to cell towers. You put a SIM on the back of it, and it connects up to T-Mobile in this case. We're using it to send data, but there's also pins on there where if we had more time, we could actually go ahead and hook up a microphone and a speaker on it. And we can use these little devices here to make phone calls on. So they have little telephone numbers associated with it. There's different types of SIMs that you can buy out there to be able to establish the connectivity. And I'm getting to your question out there. That's why we have these types of antennas here, is because they actually hook up to cell towers. And there's different types of SIMs out there. If you're paying like your typical service for AT&T, $99 a month or whatever's crazy like that, that just doesn't make a lot of sense for IoT type applications. But a company that we found, Suracom.io, for like $1 or $2 a month, I can pass a reasonable amount of data over these kind of like the cellular network. And you're not passing a lot of data, but if you have like 1 or 2 megabytes, that's actually a lot in the IoT world. So with that type of infrastructure in place, $1 or $2 a month, you can put a device on middle of nowhere essentially, have some solar panels out there, maybe some rechargeable NiCads on there and keep it going, and you can have an IoT device that's not reliant on Wi-Fi. So yeah, it's kind of a neat little thing that we're working on right now.
I'm using Google Fi as a provider, and I think they have an option to also buy data-only SIM cards.
Absolutely, absolutely, and it's really, really cheap. Like I say, you pay for it by the megabytes that you use, and it's like 7 cents per megabyte, which kind of depending on where you come from, that's either a lot of data or not very much. When you're looking at some of these small devices, we're really spending like maybe 300 bytes at a time. You can send a lot of messages 300 bytes at a time for that 7 megabytes a month. All right, so any other questions on the Visual Studio Code?
What did you just say about the last half hour or so?
I'm sorry.
You're saying something?
Drinking from a fire hose, huh? Sorry. If there's, like I say, if there's something that sounds really interesting to somebody, I can go into a lot of detail. What I'm trying to do is give an overview of what. Beer. I know. Look, Ma, no Wi-Fi needed. So we might come back to that one. That's kind of what we just showed there. We'll show how that program works because it's actually something very, very interesting. But I think what we were really going to be talking about tonight was the actual kind of the CrowPi itself. So let's jump into that. Let's play with the sensor.
When you told me to go away.
I did. You did. Still tell you to go away.
I'm hurt.
Good. That's all it took.
That's all it took. I have severe laryngitis.
That's good. All right. So now let's go ahead and talk about what this CrowPi is and why it's so freaking cool.
Now, where'd you hear about this little unit? How'd you get into this?
He's a nerd.
Well, my
Besides
job,
being a nerd.
part of my job is to be able to look on Amazon and see what cool technology is out there I don't have. And this is one of the things I didn't have. So let me see. I think the best way to do this might be to actually put the camera over here. And we'll talk about the actual CrowPi itself. See how that looks.
What's that thing called?
CrowPi.
CrowPi.
CrowPi. Yep. You can get them on Amazon. There's 2 different flavors of them. One is like $239, I think. It doesn't have a Raspberry Pi built into it. The one that I got has a Raspberry Pi built into it and has the Raspberry Pi 4, which is actually a pretty beefy little device.
Can you upgrade it when the 5 comes out?
I probably will.
I bet you will.
Okay. Zoom back this up just a little bit.
So cool.
Touchscreen. We won't spend a lot of time looking at the screen on there because it's pretty much
Looks like a bomb.
like what?
Like a bomb from a 1980 television.
That's why we call it the football. It's not kind of like the nuclear
No, the
football.
bong in
turning
your
around. So it's really neat because I mean, if you're actually working really close to it, that's a reasonable display to work on. It's touchscreen. So that's, I mean, it works good in that scenario. It's not going to work very good on our display here, so we're not going to waste any time on that. But you can kind of see the actual device itself. So let's go through some of the different types of sensors that we have on here. Obviously, this is the Raspberry Pi over here, and it has all sorts of neat connectors on it. The one here is actually kind of a USB one, so we can integrate with some USB peripherals within this kind of world here. Also, if we were looking at the display up here, since it is a touchscreen out there, the touchscreen actually works with the Raspberry Pi via USB, so it plugs in there.
.NET Core?
Pardon me?
So work with .NET Core or just regular Raspbian?
Oh, it works .NET Core, yeah. Oh, you mean IoT.NET Core?
Yeah.
You probably could, yeah. Yeah, you could.
I think I saw the
Yeah,
on
yeah,
the
you could.
website
I
that
don't know if
it
anybody's
is.
using it, but yeah.
I couldn't get a touch one to work.
Yeah, I did. I actually got touchscreen working with .NET Core.
Very cool.
Different world. But yeah, so the other neat thing is that we got Ethernet coming in here, which lets all our connectivity work together. We've got this little header here, this little header that goes between the Raspberry Pi and the actual CrowPi itself. And these are all the lines that you would normally have to go ahead and wire up yourself to be able to set up all your different sensors and all your different type of devices you're working on. If we were to take all the screws out of here, I would just be kind of probably shocked as far as like all the different wires and how all the stuff is wired in there. It's probably some circuit board stuff, but I think there's probably a lot of wires underneath there too. I have no intention of opening this thing up because I don't think I can get it back together again.
There you.
You're trouble.
You got a triple dog there.
I'll bet you.
yourself taking it apart.
What's that?
Videotape yourself taking
Come on, you know
Hey,
you get a lot of
if everybody gives me $100 each, I'll do it. You know, if I just get another one, it'd be kind of fun. A tear down or
Seems to be
something.
the price.
I'll buy you a beer.
Buy me a
2
beer.
beers, you're up to
One
2
beer.
beers.
One beer.
I'll get one too.
Yeah. Okay. Yeah, there we go. Join two. Yeah, join three.
Do I hear a six pack?
I can drink some really expensive beer. I like really expensive beer. So anyway, so we got this little kind of connector here that's going onto the board. What's really neat about it is that all these different lines have little kind of these things called LEDs on here, so you can actually see the data going back and forth, which is kind of cool. Got a little breadboard on there to be able to build up your circuits. Got basically a little mesh window on there to be able to display some messages going across there. We've got some stuff to be able to drive this little window here with some different messages. We got the power in here. We got an LCD driver for it. We got a sound chip there. We got a light sensor over here. We got so this is actually a microphone, I believe. This is where the light comes in. This is where a speaker is. I think there are different types of sound coming in. I can't remember. When we were using the motion stuff before, we were using something called infrared. So basically passive infrared, so you can put your hand over it and it detects it. Most of your motion sensors in your house do that. This is something that will detect the distance of, let's get out of the way here. The distance away, so you can move that your hand up and down like that. These are some little I/O ports to be able to connect different devices to it. I didn't bring them, but there's like servos and there's stepper motors that you can hook up to it to be able to do demonstrations on it.
It comes with some of those too. Right?
Yep, absolutely. There's a lot of stuff that you can plug into it. It's got this little blue box here. Anybody know what that is? Bonus points if you know what that is, that little blue box, if you're kind of this stuff. It's a temperature sensor, temperature and humidity sensor. So something that goes in and says, it's a digital thing. So what's neat about this is if you're familiar with temperature sensor, there's either analog or digital. This one's got a little baby computer in it, which actually does all the processing for it, so you can just ask what the temperature is. Hook up a relay here to be able to turn stuff on and off. Nice big set of buttons on there to be able to kind of press different buttons to be able to activate different features, and more buttons over here for like a joystick type thingy. What we have over here is really kind of important and really kind of neat. These little kind of switches on here are how you actually configure different sensors. If you look at all the different sensors that this thing provides, there's way more type of inputs than you have for input and output lines. So as we can switch these input and output lines on and off, we can connect different sensors. So for instance, if we want to use a specific sensor, and I think an example of them would be like a stepper motor. If you want to use a stepper motor, you might not be able to use the microphone. I'm not sure if that's the
So all
one.
the GPIOs are hardwired?
The GPIOs are hardwired to the device, the pieces that you're
Do
working
they
with.
leave any open?
Yeah, a couple down here. There's a few down here that you can connect to, but not a lot. The idea is more to be able to be self-contained. But again, what you can do is you can say that this GPIO is going to point to the stepper motor, or it's going to point to the microphone. You know, something about electronics, that's probably not a very good analogy, but you know what I'm saying there. The other neat thing that we have over here is a little RFID reader. So just kind of like when I was showing you Arduino early on with a little pig that he's going to, well, the chip that we put in there, he'll have an RFID chip in there, so we'll be able to put his little neck on there and be able to read out what his RFID tag is. This is actually RFID, not FC.
Does it work on your arm?
No, this is actually NFC on here.
Oh, no,
That's
NFC.
RFID. They're different technologies.
I'm learning.
Yep. So the big difference is RFID has got a hard-coded number of digits on it that you can only read once. NFC is something that you can program to be able to put whatever data you want on there. That's something I got in my hand. So before we jump into the sensors, any questions at some demos on the sensors? Any questions on the actual CrowPi itself? Cool. Yes.
Yeah, so it seems kind of like the old Radio Shack kind of kits that you would get.
Yeah.
So any of the things that are on here, those are readily available like separately. So you would test it on here, you would do your development, and then you would get whatever sensor you were going to work against and hook it directly to the Raspberry Pi later.
Exactly. That's exactly what the workflow would be. Absolutely. And it's really something that's kind of nice because the people that really know a lot about software maybe don't know a lot about hardware, and people that know a lot about hardware maybe don't know a lot about software. So this is people that really kind of know what the software world is like to be able to do something without really having to worry about frying any type of components out there. So yeah, this is very, very similar to the old Radio Shack electronics kits with a little spring on it where you pull the spring up and stick the water and create your little oscillator and that kind of fun stuff. Except this is, you're talking to all sorts of different devices. Any other questions? Going once, going twice. All right, so let's take a look at some of the different types of things that we can play with on this board here. Let's start out with a real simple one. Let's go to the, what would be, button matrix. I'm looking for a specific one on there. Nice simple one to be matrix demo. There we go. I'm going to close this window so we can see what's on the screen here. Okay, matrix initializing, and I'll just make this nice and big. And put the world message on the matrix display. We'll say that Joe Healy sucks eggs. Okay? Now we're going to see that.
What's this name equal name?
You ever seen a Diet Coke poured in a backpack?
What is def name? Let's see here. It looks like this is just. Well, that's a good question. I mean, well, the essentially is. I mean, this is actually something Python is an interpretive type of language. So somewhere on their name is defined, and I don't know where it's actually defined at on this particular type of program. Maybe it's at the top up there.
I think it's like a reserved word, like so it's checking to see if you're in the main function.
Oh, okay, so you can run it from other applications. Thank you. Yeah, exactly. Yeah.
We now have a Python viewer.
Yes, thank you.
I like this.
Go.
So now if we come back over here and we can go ahead and come back into Terminus, we can do ls, not ks, and we'll say that. Where did I go? CrowPi, I don't know how I got there. I wonder if maybe my .NET, maybe it was in a different directory and that's why. Yeah, well. And I can say Python. What was that? Matrix demo, I believe. So now we can sort that other and we can see on the screen. If we come back to the.
Oh, there it goes.
Yep.
Just write that. Is that in code?
And tonight we're giving away this backpack.
So you can see it was a nice simple program that we wrote that was able to, and how many lines of code is that? Very, very few lines of code to be able to call that up. What we're doing here is being able to bring all these these drivers in. So a lot of times, remember we were talking about in the Arduino, where we have these different type of libraries that we bring in to be able to manage your different types of applications, be able to provide additional functionality. If we had maybe 4 or 6 hours, we could figure out how to use the I2C to be able to communicate to it and send the data over, or whatever that is. Doesn't really matter. Or we can find this library in this case, which is, it's hard to believe it's so difficult to read out there, called Luma, which we can bring into our application, use that automatically. And when you use Python, pip, I think, is what you use to be able to bring your library manager in, if I remember right. So pip is a tool to be able to manage your libraries, to be able to bring in Luma, to be able to, well, it's great stuff.
You'll hear some beers.
All right, so let's see what other type of exciting stuff we can do here. Obviously, those are the more interesting ones because they actually show some lights on the screen. 7 segment, that's kind of a neat one. Yeah, let's go ahead and let's make a clock. Let's make a clock. LS. I'll just segment, I guess. The other thing, nice little feature if you're working in, even works in prompt and DOS. Start typing the first few letters, it goes in and does the completion when you hit tab on there, which makes it a little nice. So you can now see, we come back to our camera. Let's see, let's go down a little bit and bring up the camera. We can see that now we have 1849, so it looks like we maybe aren't compensating for daylight savings time or something on that clock, so we're probably off by an hour maybe. We're off by quite a bit. If anybody wants to help me debug that Python program, we can certainly do that, but the idea is...
You already owe about 4 beers.
So we can get the daytime.now on there, which apparently... Oh, I know exactly why this is happening.
GTC now.
Nope, because what's happening is, remember we're having some internet connectivity challenges? When we look at this little globe on here, we're not hooking up to the internet. So the Raspberry Pi doesn't have a built-in real-time clock. So anytime you need to get the date time, it needs to go up to the internet and, what is it, an NNTP server, I think? Plug in.
C# I can't see, but you have a 2-point font.
Yeah,
Try
see because
UTC now.
how's that?
Try UT.
No, the problem is we're not hooked up to the internet, so the Raspberry Pi can't go up to the internet and ask what time it is. But that's why we're seeing a different time on there. And yeah, so that's kind of an important thing when you're working embedded systems like this. There's things called real-time clock or RTCs out there. They usually require a little battery in there. When you have that, then you can maintain the kind of the date and time when you actually power down the device. But we don't really have one on the Raspberry Pi, and we can't get the internet, and therefore we come over here. We can see that we're 1850 for those folks that know 24-hour time, which is 6:50 p.m. as opposed to what it is at 8 o'clock or here 30. All right.
So if there's connectivity issue, where is it getting that? Since I didn't have that.
I'm sorry.
So where is it getting that time from if it's not?
Oh, basically, well, that's a good question. Let's go ahead and do something. Let's do a little program. That's a really good question.
Because I mean, wouldn't it be like 0000 if it was like just reset and then just
Print now. Let's go ahead and so have to put that in there. So again, we're working with the program on here, and what we're going to do is we're going to see what that time actually is. Remember, we have WinSCP running, so it's automatically pushing our programs across. And where did I term yes? Right there, I guess. We'll hit Control-C to exit that program. Now we'll do it again, and the first thing it should have is the date time on there. Oh, look at that. Somehow
it's getting data.
yeah,
somewhere.
it looks like it is off. Well, it's off by a little bit. So maybe, I don't know, maybe that was the last time it was running or something. I don't know where it got it from because there's no real-time clock in there and it didn't reach out to the internet, so I'm not really sure where that came from.
Russians did it.
Probably. All right, so any other type of sensors people want me to take a peek at?
Could you use like the light sensors input and the microphone, I mean the speaker's output and convert light to sound?
We sure could. Well, let's see if we can figure that one out. Great question. Let's go ahead and do a little programming. I might need your Python help here. Okay, so our light sensor, so we'll figure this out. Let's just run the light sensor to start with, and we'll hit Control-C, and we'll say ls. We'll see what we got. Python light sensor. Now it should say the light level of 122 because we got those bright lights on there. If we trust me, I'm going to put my hand over this little thing that you can't see anyways, which is the light sensor. There we go. It's right there, I guess. Should be dropping down. So there we go. So now you still can't see that. Where's my critic over here telling me to let me figure?
You could like put it on the little display if you weren't lazy.
Huh? Put it on the display. Put that thing on there?
Yeah. Put the light meter on the display. And then use the IPVO to show it. Or do that way.
I don't know what you're talking about, really.
You have that little thing that keeps showing the not correct time on there. You can put the light meter there.
That's what we're doing right now, though. Never mind. Confused the hell out of me.
On your little CrowPi,
Yeah.
there's a little display.
Oh, Yeah, you're right. We could program that too. I got
It's
you.
all- it's programming.
I don't like programming computers actually. Okay, so now we know that we got a little program on here which will grab.
Friggin' butt mask.
Do all these examples come with the CrowPi?
Yes, that's a great question. So again, when you actually get the CrowPi, there's actually a SD card in it. SD cards are basically the storage that sits in there. And there's a folder called CrowPi, and underneath that there's examples, and all those examples are in there.
Probably the time lips too.
Likely so. All right, so convert to number, read light. So all we really should have to do is come over here to the speaker. A button buzzer. I'm just going to copy this little program. So time, I don't think I need any more stuff. So I'm going to do Control C and then Control Tab. Lets me change between the different kind of the windows we got open. Where'd my light sensor go? And right here, brightness level. If sensor dot read light. You can see that's the nice thing about working with the IntelliSense on here. If we were working with Vim or kind of Nano on there, you wouldn't have the read light on there. So like that. It's greater than, we'll say 50. Actually, we'll say if it's less than 50 because normal state will be having the microphone off. No, speaker, thank you. I'm already thinking about that next uncle.
We're about to convert light to sound.
Yeah, this is exciting. Okay, so what we're going to do now is we're going to set up the
Star Trek with the whales episode.
we're going to go ahead and I'll just do the code right here just because we'll get it done. I'll explain what we're doing here. So, yeah, this isn't going to run, is it? Remember, this is a Python application. Somebody tell me why this is going to be a big problem. No doubting. So I'm going to come over here and run that to your question, ask you if it lets you know what, when you ask as far as what it'll tell you. And I'm going to go down here and we'll say Control C and we'll do my up arrow trick and it'll say that indentation there. So it basically says in a very clear, it'll even tell you what line it is, which is really good for people like that.
Bad at all.
Okay, so now I'm going to come over here to Visual Studio and fix my programming bugs. We don't care about the button pin. We'll get rid of that one. And we'll make sure that everything's lined up here. Comments I don't think need to be indented, but we'll do it anyways. So what we're doing here is, who can tell me what GPIO stands for? Exactly, by that end of year. So what we're doing here is when you have your board in place, you have a lot of I/O lines on there. So you have to really tell how you want the system to work. So we're going to say that we're going to set the mode on the GPIO pin to be BCM for there. So we're setting the GPIO into that particular mode. So this says they're setting the board into GPIO BCM mode. It's a specific way to be able to send your inputs and outputs out there. So we may run into some challenges here because there might be some conflicts between these two things. But we'll see where we get going here. We're not going to use the button. We're going to use the light instead, right? Okay, so I'm going to come up here and I'll bring it back up again. So Control Tab will go into the button buzzer. And this will be easy. Control C, Control Tab, go back there. And let's zoom into that screen again. And oh, does anybody else know what's wrong with my little program here? Something just doesn't look right, does it? I guess I got a little muscle memory going on there maybe, huh? So we'll get rid of this one. And we'll say else. And then we'll come down here and we'll say Control C, Control V. We'll line up our little windows here. So now in theory, so somebody find the bugs that I got here. I think it might be pretty.
Some colons.
Yes, a colon. Thank you. Yes. All right, somebody else find another bug so we can run this thing the first time.
And I'll
You're high and low.
Yeah.
Well, you're printing the
Yeah.
same thing either way.
You got them both high.
Oh, jeez. My mind is somewhere else, I guess. Here.
Were you,
break on
were you
that.
hanging out with Joe before?
One beer, I promise. That's
One,
all I did.
one, just one,
One
just
beer.
one, just one.
We were in off ground
That's all
though, so
we
you know what happens there, right?
Do you need to break that while loop?
What's that?
I'm might be wrong. Do you need to add a break to that while loop?
I don't think so. I don't think so. We're gonna continue to run there, so it's gonna continue to run forever, right? Yeah, in this case, we're always gonna sample. That's a good question, but in this case,
Right.
well, I mean, we could say that, hey, if I get a light less than a certain level, then we wanna be able to, break, but in this case, we wanna run forever. So I think this is gonna be pretty darn close. No guarantees. I'm not gonna bet my next beer on it.
The pre-compiler and win for Python.
There is actually.
Kevin, if it runs the first time, I'll buy you a beer.
Ooh.
I'm gonna check it again. Check it one more time here.
I gotta look at that code again.
Okay, so it's running. So now I need a helper from the audience. Anybody feel like getting up so I don't have to? Yeah, there we go. I'll tell you where to look. Yeah, go ahead.
We're gonna be.
So right underneath the display there, right underneath the seven, here, hold on, let me get this nice and big here. There we go. Right underneath that 7-segment display, right next to that little speaker thing there should be a microphone. So just kind of put your hand in that general area.
It's a light sensor they're doing?
No, I think it's
Just
actually
make
just a little
shadow.
bit to my side of that.
Hold your hand, hover
Yeah.
your hand.
There you go. Oh, this thing.
Yeah, it's somewhere one of those there.
Oh, these guys. This looks like
No, it's actually, I think it's like right around, oh, I'm getting up anyways.
Hold his hand, put it where it goes.
It's one of these guys on there.
Game just find the sense somehow.
All right, pretty cool, huh?
You just
It's
really
a tricky
Twitter
refresh rate.
Yay! Let's do something else. Let's go ahead. We're going crazy now. So I'm gonna go. Is that like double or nothing on the beer there, Bill? So if I get something else
Well,
working,
well, you get one on that for sure.
I get one on that
Now
for sure.
show some wiring and
So I do have a
actual
question.
fire check.
That's a
Kevin, I do
different
have a
project.
question for you.
What's that?
I have a question for you.
Yes, yes, sir.
So when it comes to .NET, so
Yes.
these devices are limited in storage and things like that. So the overhead of .NET, is that a big deal?
Great question. Raspberry Pi really isn't that limited. For example, our company's product runs on a Linux box running 512 megabytes of RAM. Raspberry Pi has 4 gigabytes of RAM on it, and it's got like 4 cores on there. So that's actually really, really advanced for that. When we're talking about some of the Arduino type devices and some of the other smaller devices on there, yeah, that's a little bit different. There was something called the Microsoft.NET Micro Framework at one time that people used for that. That kind of fell out of fashion. I guess it just really wasn't supported and kind of makes sense. There's some, we could talk about it. That's actually a really good question because there's a lot of value in running .NET at that level.
So on mobile devices, when you're using .NET, typically you have to embed the .NET framework into the application. You have to do the same sort of thing here, or can you access shared libraries?
And a lot of times when you're running these, I mean, it's kind of a design strategy where you want to make the best use of that. So with .NET Core, I mean, it's running native code on there. It's running the actual kind of native stuff underneath there. So that's kind of neat, powerful. So what you wanted, I don't know a lot of people that would necessarily be running .NET Core natively on a Linux box. I think if you're going to be going with that strategy, you're going to be looking for something like Docker to be able to kind of deploy your applications all over the place. I mean, it's self-contained at that point, so you have all the libraries that you need in there. But it is self-contained. I mean, when you actually do a publish of the application for .NET, it will have everything you need on there, so you don't need to have anything additional on there besides the .NET Core, the kind of like the .NET interpreter and all that type of stuff there. But any other type of libraries you would actually deploy with like a NuGet type of thing. Did that answer your question or not really?
Yeah, well, so generally you're not really concerned about storage.
Well, because I mean, thinking about it, when you talk about storage, the big thing that you're worried about isn't necessarily how many megabytes your program is or even gigabytes, because 16 gigabyte SD card for $32, who cares? What you're normally worrying about is the actual RAM on the device. That's really kind of what your limiting factor is. Like I said, we're running some very sophisticated large applications and 512 megabytes of RAM. So I mean, that's really not an issue either.
I guess it's a little different than like on a mobile phone where you might have 100 apps installed or whatever. This is generally more like you have a tailored app specific
Yes.
to the device.
For embedded, yes, for embedded type systems. And that's a whole different topic when we start talking about those types of things. When you're building an embedded system, you're really generally worried about two different things. One is building a very sophisticated application with lots of business logic on it, lots of rules, and maybe some LML and those type of things. That's one part of the equation. The other part of the equation is I want things to happen really, really fast, within like sub-microseconds when I want to be able to sample. Let's say I'm doing some digital signal processing on some type of vibrations, monitoring some type of motor out there. You want to be able to come up with code that's not going to take 20 milliseconds. I mean, that sounds like a long time for people, but 20 milliseconds in terms of computers is just not that, that's a very, very long amount of time. So when you're building those types of applications where you want to be able to collect data very, very quickly, you want to be able to write it in some low-level C. And in that case, you're generally not going to use a language that's kind of like .NET. I mean, it's just not going to run that fast. Garbage collected language. You want to have something that just runs on the bare metal and executes directly on the CPU to be able to put stuff. So there's just so many variables, and it's just a lot of variables.
So if you were, so I saw you a lot of stuff you write Python instead of .NET. So is there a decision point where you pick .NET over Python, or does that do with like size of the application or maintenance?
If I was going to build an embedded system that ran on a Raspberry Pi, I probably would not write in Python. I would not. We're doing that because it's just simple. It's good for demos, exactly. And it's good for machine learning.
All your Python is stock demos, right?
What's that?
All your Python.
Yeah, exactly.
So he's running the stock demos.
Right. Yeah, I mean, if you're going to be doing something that's collecting samples at like 2,000 times a second, you're not going to write that in Python. That's just not the right answer. You might actually use Python. Well, Python's really cool because you can write Python applications that communicate to native applications running lower on there. So you can do the stuff that's really, really fast to collect the data in C, but then you have a Python on top of it. And then when you use Python, you can start bringing in TensorFlow or Cognitive Toolkit to be able to look at the data. So it's a way to glue stuff together. Python's a really good language to glue stuff together, but you're never going to get the performance. That's a good question.
I know that there was a project I was working on that was doing machine learning and it was doing image recognition.
Yep.
And it was on Linux, and they had a Python interface, but they didn't have a .NET interface available.
Okay.
So yeah, I mean, I understand about
Python
being like they'll write this at low level and something really efficient, but then give a Python interface to it. So
Yep. It glues stuff together really quick. I mean, it's really, really good for that. But I mean, Node, I think, is, I don't know, a lot of people use Node for writing applications on Raspberry Pi. That seems like a better way of doing it to be able to do things. So what are the questions? These are really good questions. Any topics? Any other topics just in general, or do we want to try to do some more demos, or do you want to just go grab a beer, or what do you guys want to do?
I was going to ask, would you use that in a hackathon?
Could use this in a hackathon. Use a CrowPi? Sure. Why not? Absolutely. And that's just it. I mean, the longer we work with this, the more tools that you understand and the more stuff that you pull together. Something that we didn't talk about tonight that's really, really important if you do this type of work is MQTT. How many people know what MQTT is? If you do any type of work with embedded systems, with connectivity, with IoT, you really, really want to spend some time looking at that. MQTT is essentially a publish-subscribe type architecture, because when you have a device running out in the field out there, I guess the best way to describe it is you got a device running in the field out there and you want to talk to a server, right? If I'm just using a simple REST type of call where the device is actually making a call to the server, say, hey, give me some data, this is my update, so on and so forth, that's good, and there's a lot of value to that. But in a lot of cases when you build these systems, you may want to be able to send a message down to the device to say, some condition happened over here, you need to go ahead and deal with it on the device. So in that case, what you do is you have your device subscribing to something called a topic on the server, and then any type of messages get published to that topic, they get sent down to the device. It's just kind of a way to be able to set up a mesh type of network to be able to send stuff in. I'm going to get you, what's that? What's that? You know that one? Okay. Yeah. So yeah, that makes sense. Any question? Like I say, that's a really important thing that we didn't get into tonight, but it's something that if you do any of this type of programming, it's really, really important to understand. What's neat about MQTT is that when we actually started working with the cellular type service, you can bring a library in. It's really, really easy to bring a library in and get that one up and running. But one of the real powers of MQTT is how incredibly small it is and how incredibly efficient it is. as far as the bytes that you're sending around. So if you're using a cell connection to be able to send data between all these different points out there, you don't want to be passing megabytes of data. You can use something like MQTT where you're passing in literally tens and 20s and maybe 100 bytes every once in a while. So over the course of the month, you're just not using all the data. But really, it's an important thing if you'd be able to do this type of work to be able to look into something called MQTT.
But it also includes the whole message quality thing as well.
Yes.
So that you don't have to worry about messages getting lost or not delivered.
Absolutely. There's a whole type of architecture in there that makes it, it's called reliable messaging, I think, isn't it, maybe? Yeah, and then it has its bigger brother, AMQP, which is a lot more sophisticated, a lot more secure. But a lot of times running AMQP, it's maybe not going to work as well on a small little Arduino where your constraints, like Bill was saying, are very, very limited. All right, so any other questions? These are great questions, and I could talk about the stuff for hours upon hours. And
Where would you recommend somebody get started? Just pick up a Raspberry Pi and go, or?
Yes. Yes, Raspberry Pi is a good way to start. So there's really kind of two different, that's another good question. So there's really kind of two different avenues you can take when you start looking at doing IoT and embedded systems. One is doing something with like a Raspberry Pi where you're programming for all practical purposes in Linux, and you're writing a Python script, you're writing the Node script, and you're doing some really incredibly powerful things to be able to pass messages around. The other avenue that you can go, and it's a little bit more expensive. I mean, Raspberry Pi Zero, you can get them for $20 with wireless.
A little starter kit on Pi with everything you really want to do, probably going to cost about $120.
Yeah. So it's really easy to get started like that.
And that's where the CrowPi kind of comes in. For $300, you get a little dedicated HDMI display.
Yep.
You get network board. You get all these little things that you want to play with. If you're going to go $100, we're all making money. Do the $300. That kit works.
The other part about that is time. I mean, you could buy all this stuff and wire it up, and you're going to spend literally a full weekend just trying to get these sensors working. So like I say, that's one avenue that you can do is you can kind of play at the level of Raspberry Pi where you're doing Linux programming, which is likely probably going to be Python or Node or maybe .NET. The other avenue that you can go to is these types of devices, which are really kind of neat. And they're a little bit less expensive, but they're also a little bit more powerful. I've got two examples of them right here. This could be part of our phone. So one is this little guy right here, which is called something called an ESP32. Is anybody familiar with that? An ESP32 or the ESP8266?
Damn hands go up.
Yeah. So it's a really, really cheap device, and this is something where you can actually build some kind of like real-time stuff on it. Remember we were talking about, hey, I want to sample this thing at 20k hertz to be able to pull the data in. You can do it on here, and this is really, really cheap. This one actually has all connection built into it.
Oh, wow.
This is one up here that has another little block. It's called an M5 stack, and it has kind of like a little, it's kind of like this here, where you could actually have like a little display on the top of it. And like I say, when we're done here, I'll get more details if people want to come up here and I can show stuff. But it has like a little stack, so you can basically have like just this type of board. It's the same type of technology, except it's a different kind of form factor. So you can like put something on there that's maybe a modem, another one that's a speaker, another one that's a GPS. You kind of get to build this whole thing up in a nice little self-contained little block here. But again, that's kind of a different avenue because in that case, what you're doing is Arduino programming, where over there you're doing Node or Python or C# or something like that. So on that, oh, yes, sir.
Super general question.
Yes, of course.
When you needed to relearn a language, what's the best way to do that in a time-efficient way, but also in a way where you're...
Oh boy, that's a very, very good question over a beer. As you know, as you can probably tell, I've been doing this for a long time. I've kind of been doing this for a long time, and when I went to school, I went for electrical engineering and assembler and kind of like all the ways, I'm getting the question, I promise. And kind of understanding how like shift registers work and logic stuff works inside a chip like that. So once you understand that, it's kind of like learning Latin. Once you understand how that stuff works, languages are built on top of that.
Right.
And
Because they're Sanskrit.
so just kind of understanding the real basics and the core building blocks of how computers work. Understanding why strings are bad and char binaries are good, depending on what your type you're doing. But just, I kind of feel sorry for people coming into the industry right now because it's just like drinking from a fire hose. You have to be kind of a generalist in that you have to kind of know a little bit of everything and not kind of like pick one area that you're really, really focused on, be really, really good at it. And I'm not sure if there's a really good answer to be able to pick up new languages other than just kind of really understanding the fundamentals of how computers work.
Oh, absolutely.
So I don't think that was a very good answer, but
No, yeah, it was actually. It's like-
Pluralsight's a good
Oh,
way to
sure,
start
sure.
as well.
Oh,
if you
yeah,
want-
yeah.
If you just want to get a good,
But I mean,
Well,
learn
understand.
C. If you don't know C, C is a great place to start. I would say if you learn,
Eventually,
but that's a good way to start because that teaches you the control structures that really, I mean, a lot of languages are kind of loosely based on C. So you know C, then you know C++, and you know .NET, and then you know Java, and then maybe you know a little bit of Node on there. It's all the same type of structures. But I mean, really, like I say, learning a new language, I don't know, I've just been doing this for so long that learning a new language just isn't that terribly difficult because every time here's an answer to that. Every time you see a new problem come up in computer science or software engineering and doing those types of things, you kind of know what you want it to do, and you just got to figure out the right way to be able to solve that problem and translate that onto the language that you're currently working in. So really kind of learn what the algorithms are and learn kind of the core things that you do for building systems as opposed to learning the language, because then you can always translate what you kind of want it to do into a language. And a lot of times,
I totally know. So I just heard that I was doing some research. I'm very, very new to programming, but that C is more functional language.
not really.
No.
Not really.
What is it? Object-oriented programs can be too top-heavy to make really good algorithms, and so C is really good for.
Yeah, we'll talk about that one over beer.
Cool.
That's good. That's good.
Yeah.
So I think another thing too with that is understanding that in the world that we live in right now, it's less about even understanding a language and more about understanding the libraries that are out there. So for instance, we're doing a project right now where we're doing some digital signal processing, and I started out by just pulling a link, kind of like something in for doing something called an FFT, fast Fourier transform, and it's like, boy, this is crazy code. So it's more about understanding what the algorithm that you wanted to be able to implement is. Then you pull the library in to solve the problem as opposed to writing that from scratch. I ended up having to write something from scratch, but that was nuts. So it's more understanding about the types of things you can do with the computer and then translating them into the language that you're currently working on and then finding the library to solve the problem. A perfect example, when we were like showing the LEDs on there to be able to pull the data on there, yes, we could have actually talked to the I2C bus. We could have been able to figure out how to like toggle this thing on at the right time. We just brought a library in to solve that problem. You're just working at a different level, something called abstraction. You're abstracting away the details of that problem and you're building the implementation, kind of the business logic layer. So I mean, it's just, like I said, it's a fun journey. I'm excited for you because what we're going to be doing for the next 20 years is just going to be incredibly interesting. Any other questions?
I might have something.
Yes.
I looked into stuff years ago and never did much with it, but I was very intrigued by a concept that doesn't require external power sources for sensors or perhaps even actuators. I'm talking like light switch, for instance. You know, it's like its own device, doesn't have a battery inside it, and simply by flicking the switch, it creates enough power to create a signal to be received by whatever receiver.
Yeah.
Do you know anything more about that?
The only thing that I know, well, a little bit. I mean, there's like the watches, obviously, that use the kind of the kinetic energy in your hand like that. A lot of stuff is, I mean, that's more of a physics type of question, I guess. Saying that it's kind of like one kind of application of that is like the little chip that I have in my hand in there. The chip will run forever, and what happens is when I take my phone and my phone on top of it, the actual power from the phone will actually kind of energize the chip to be able to send the signal out. And that's not really what you're talking about. You're talking about using some type of kinetic energy to be able to.
Yeah.
So yeah.
Or like sometimes you have like a temperature difference
Sure.
that isn't able to create enough energy to drive something. Or perhaps you might even install a small solar panel and
Yes.
Okay,
yeah. For those types of things, yeah.
To store energy that might produce enough to send out the signal, you know, every 10 minutes or so.
Yes. So when you talk about solar, that's one thing. When you're talking about kinetic, that's very different. I don't know anything about that. I know a little bit about solar stuff, so it's very interesting stuff.
Oh, I was just talking about the general idea of not having to rely on an external power source.
Well, what's neat about that is too, if you can do that where you're sending a signal in every 30 minutes and you have a little cell connection, so you can just drop a piece of equipment in the middle of nowhere and it just works.
Right.
It's really neat. Kelvin, you had a question back there? Pardon me?
Not in California.
No, what I need to do is I need to find more hackathons. I mean, they're just the kind of few and far between
Have
right
you
now.
ever entered a hackathon?
Have I?
Yes, and
No.
anything.
Nah, not really, not really.
Tell them what you did.
Tell them what you did.
I didn't do anything.
You said Adderall, if I remember.
Adderall, yeah. Bikemaster put together a team. Went to
Oh,
Vegas,
you can't
included
talk.
Kelvin, coached the whole thing. We took down 75 grand at the hackathon under his coaching.
75 grand.
75 grand.
It was pretty cool, yeah. It's AT&T Mobile Hackathon, and we just did it because we like Vegas and drinking beer, but there was a programming competition out there at the same time, so we competed in that. And out of 300 teams, the team that we put together seemed to do pretty good. The first place. And we actually went on a road tour with Aero Electronics and, come on, the big
Qualcomm.
cell company, Qualcomm, thank you, Qualcomm. They sponsored us to be able to go to some different shows after that, be able to show what we did for technology.
Dragon board.
Dragon board. Yep. So that was pretty fun. So
And the band.
and up there,
Who'd you
yeah.
get a picture with?
Billy Idol up there in front. That's pretty cool. That was a good trip. That was like a classic trip. All right. So I think we're probably kind of.
There's a long story there. You guys don't ever hesitate to enter hackathons. You got the skills to do it. Just set up your plan beforehand, because he literally had us go to. We didn't pre-rig the apps, but we did learn the tech we were using for 3 weeks beforehand. We had little mandatory Saturday sessions where we just worked on shit.
And the important thing for the hackathon to learn is part of it is the technology. The technology has to be good and it has to work. The big part is the story, though. We came up with a really great story, a very compelling story, and we had Kelvin up on stage. I don't think he had tears coming out of your eyes, but I know Joe did for a while. That was contributing for part of the story.
I'm a
so.
crier.
You cried a little bit.
He was talking about my dead dad. What do you expect?
I
You know?
But yeah, it was really neat because we were on stage in front of like 300 people and they were streaming this thing all over, and we were the top 3 entries, and we somehow came out first place, which was pretty cool. And Kelvin did a great demo there along with another buddy of ours who wasn't able to make it tonight. All right, any last questions before we hand it back to John? And then like I say, I'll give some more tours on the technology before we head out.
What do you use your chip can thing for?
Yeah.
Public relations. People remember me when they come up to my phone. No, it's actually, it's a very small signal in there, so you have to put the phone exactly right on there. But it's really kind of neat because people remember me for that for some strange reason, that I've got a chip implanted in my hand. I don't know. But yeah, so basically, if you put your phone on there, it'll bring up my website, my company's website.
Oh, okay.
Yeah.
Mighty.
Thank you. Any other questions? Like I say, come up here afterwards, and I'll be grabbing a beer somewhere.
Where?
You got cards?
Yeah, I'll grab some cards here.
So thanks, Kevin.
Where's yours, Joe?
Thank you.
We'll walk down the street to the avenue, and we'll put some tables together. They're usually pretty good about.
Outside or inside?
It depends on where they have space. So they have heaters outside. I know it's a little chilly for Florida right now. So they're pretty good about allowing us to put tables together. So please, if you are so inclined, join us. Drink responsibly on your own dime. With that, we are at Suncoast Developer Guild next month, Wednesday, March 18th, I think, for the Blazer Roadshow with Carl Franklin. Please be sure to RSVP. We might actually cap the RSVP just to reserve space and food. There will be food provided. It's going to be a full 3 hours from 6 to 9. It's going to be a great time. I'm not going to be there, so Clayton and probably Aaron are going to help run the festivities that night. So please have a lot of fun. But with that, we're going to look for additional sponsors and speakers and topics in the future. So if you have anything of interest, then be sure to let us know. Join the discussion on meetup.com. Join us on Facebook if that's your thing. Watch YouTube when videos get up there sometimes. And follow us on Twitter. All right, with that, thanks everybody for coming.
Quick note, this next meeting is like huge. Having Carl Franklin here, if you don't know who he is, you really want to RSVP because it's going to be great. If you haven't met him before, he's incredibly great speaker.